A certain math department has 9 full-time faculty, 5 part-time faculty, and 3 teaching assistants, and 2 people are to be selected to go to a conference. So I'm going to answer these 3 questions here. What is the probability that at least one person selected is a full-time faculty? Also, what is the probability that no teaching assistant attends? And what is the probability that exactly one part-time faculty attends? Okay. Now, this is so-called without replacement, right? Once we select the first person, okay, we don't put that person back into the pool and then draw the second one, right? Okay, so that's just naturally assumed because in this case we are selecting people, okay? Now in this case it's going to be easier to do a tree diagram here, okay? So in this case we're going to select between one of the full-timers, one of the part-timers, or one of the teaching assistants, right? So I'm just going to put full for short here. Okay, so full-timer or a part-timer or a TA. Okay, and we know that there's actually how many people total here? There's 17 total, right? So the probability that the first person is a full-time faculty, that's going to be 9 out of 17. Right? The probability that the first person is a part-timer is 5 out of 17. And the probability that the first person selected the TA is 3 out of the 17. Okay. But now remember, there has to be a second person selected here, right? So that means out of each of these, there should be 3 more paths, okay? Because we have to select, once again, either a full-timer, a part-timer, or a TA. So let me write those down here, right? Full-timer, part-timer, TA. So we've got another full-timer, part-timer, and TA. So remember, this is assuming that the full-timer was picked first. This was assuming the part-timer was picked first here. And then similarly, this last node, right, the TA was picked first, but then we can pick a full-timer after that, or a part-timer, or a TA, right? But what are the probabilities, right? So if we know that the first person picked was a full-timer, what's the probability that the second person picked is a full-timer? Okay, well, there's 8 full-timers left because that first one has already been picked, and there are 16 people left. Okay. So what about the part-timer here? I put time there, right? What about the part-timer? Okay. How many part-timers are there? Remember, we've assumed that the first person picked was a full-timer, so then this should be 5 out of 16, right? Because there's 16 people left, 5 of them are part-timers. So this should be 3 out of 16. Okay. So what about this branch here? Right, part-timer was picked first. What's the probability that the full-timer will be picked second? Well, there are 9 full-timers out of the 16 remaining, right? Here, there's going to be 4 part-timers out of the 16 remaining. And here, there will be 3 TAs out of the 16 remaining. Okay, so here, a TA was picked first, right? That's a 3 out of 17 chance. Then what's the probability that the full-timer is picked second? Assuming that the TA was picked first, right? Well, that's going to be 9 out of 16 because there's 9 full-timers left. This will be 5 out of 16 because there's still 5 part-timers remaining. And then, once again, this one where the number changes, right? There's 3 TAs, one of them was picked first, so there's a 2 out of 16 chance that the TA is picked second. Right, so now we want to multiply these together, right? So what's the probability you get a full-timer first and a full-timer second? Okay, well, multiplying these together, we get what? 72 out of 272. And then a full-timer first, part-timer second, there's a 45 out of 272 chance. And then a full-timer first, TA second, is 27 out of 272. So then similarly, the probability you get a part-timer and then a full-timer is 45, right? This will be 20 out of 272, this will be 15. And then a TA is picked first, then a full-timer is 27. TA and then part-timer is 15. And then TA and then TA, that's 6. Right, so we actually see that that one has the smallest chance of occurring, which makes sense because there's the least number of TAs here, right? All right, so what's the probability that at least one full-time faculty attends? That's at least one full-time faculty, right? So once again, we're only picking 2 people though, right? So we want to find all the branches that have at least one full-timer. Okay, so at least one full-timer. Yeah, so what is that going to be? Well, this one has 2, right? But that's okay. So that's going to be 72. And this one has at least one full-timer. And this branch as well, right? That has at least one full-timer. And there's going to be this one here that has a full-timer there, right? Part-timer and then full-timer picked. And then this one is the last one here, right? 27 out of 272. So we added all of these and the 5 numbers together, we get 216 out of 272. Pretty big chance, right? Which sort of makes sense because there's more full-timers than any of the others, right? So there's a 216 out of 272 chance that at least one full-timer is selected. What is the probability that no TAs attends, right? No TAs. So what do we have to do? Well, we have to go through the branches, or the paths, I should say, and determine which ones have no TAs in them. Okay? Well, this one does, right? The 72 out of 272, right? And then this one also has no TA, so that's 45. You notice that this one has a TA, right? So we cannot include that. So we're going to include then the 45 here. And then in this case, the 20. And you notice that this path has a TA, so we can't include that one. And similarly, right, all of these 3 paths have a TA as well, right? So we can't include any of these either. Okay? So we want to add these 4 numbers together, right? In this case, we get 182. Right? So there is a 182 out of 272 chance that no TA will attend. What about the last one? What is the probability that exactly one part-timer attends? So we want to once again go through all the branches and pick the ones that have exactly one part-timer. Right, that's going to be this one here. So that's the 45. And then you notice that this one, the part-timer is picked first, right? So we'll pick this one that has one part-timer. And this one as well, right? So this path has only one part-timer. That's going to be 15. And then what about this one right here, right? We want to pick this path, the TA, and then the part-timers. That's going to be 15 out of 272. So when we add these 4 numbers together in this case, right, we get 120 out of 272. There is a 120 out of 272 chance that exactly one part-timer will attend this conference.